Hello everyone, my name is Carl Sinagra and today I will be presenting my final project for the fall 2016 semester for CS6963 Digital Forensics course. The tool that I'm presenting and going to have a video demonstration on is called the CS iOS Extractor tool. This was a Python script sourced from Chris Crosby's iOS 6 recovery tool that was presented in Sci4 under the module for the summer of 2013 final projects. The reason for choosing this project was due to my interest in Christopher Crosby's tool and how he was able to extract specific data from an iOS 6 backup. Another reason for choosing this topic was because during the fall of 2016 semester, security researchers figured out that the iOS 10 backups were using a weak encryption algorithm that was vulnerable to an attack. This ultimately meant that an adversary could easily break the encryption and have access to the iOS 10 backups that were stored on the machine. The tool that I'm presenting doesn't exploit this vulnerability. It does, however, extract data from an iOS 10 backup, which by default isn't encrypted when backing up in iTunes. Now, this prompted me to improve on Crisp's tool and to add some more features. And I never really noticed that the iTunes doesn't automatically enable encryption when backing up your phone. And after doing this project, I have now realized that it's imperative to make sure you check off that option. So I basically have, when looking at the code, I determined that I would have to upload two different versions for this project, a version 1 and a version 2 of my CSIOS extractor tool. Version 1 is going to be something that you run against an iOS backup that is less than version 10, and obviously version 2 is going to be the code for running against a iOS 10 backup. Now, this came to be from looking at the source code of Chris Crosby and ultimately rewriting that tool to take into account if the directory structure for the iOS 10 backups were the same, which they weren't in, looking at comparing an older backup file that I had to an iOS 10 version that I had. Was the database structure of the iOS files the same? So in Chris Crosby's tool, he's calling to a specific database file within the iOS that was mostly sourced from a here, which was an iOS iPhone backup extractor location of the files. And for version 6, it tells you that the SMS content, and I'll go over this when we look into the actual iOS backup, but the backup file name is a SHA-1 encrypted name that basically tells us that it's a database file and it houses SMS. So Chris Crosby then went through all these files and was able to run a SQLite command to extract this data from these files. Now, the other item was that, what other changes and improvements would I be able to make? So let's go to the code first here, and I use Sublime Text. And as you can see, the first thing that I'm showing here is the CS iOS Extractor version 1 Python script. Ultimately, the different modules and libraries that I used here, I had placed inline comments and had to figure out why Chris Crosby was using these different tools. The most important one was import OS, along with logging, SQLite 3, and plistlib. Some of the other things in here I included for myself when I was doing another Python script for this semester. And the bulk of the items here, and also the feature that I made was that I changed Arc to use ArcParse instead of options, which was one of the things that he had going on. But to go back to the code here real quick, we are identifying what the item is, the file within the backup structure. So we are identifying the function identify JPEG is doing a binary read. So we're going to open up the file. We're going to read it and read 11 lines of it. And then for 4 of the hex values here, that was pulled from Gary Kessler's file signature table database, which we knew was used in our file analysis project, or assignment, I should say. So taking these values and putting them in here would traverse through the backup and look to see if it met any of these file signatures. And if it did, the functions to capture the data would copy it down and drop it into the destination path that we provided to it, and appends the proper file extension to it so that we'd be able to open up this file and see the contents. Otherwise, we're not going to be able to do much with a blank file. So some of the things that I did was I kept the JPEG and PNG, and then I figured out a way to include a PDF extractor, which I have here, and also the voicemail, which was originally in Chris Crosby's tool. I also added a identify movie, which is like, if you're filming from your phone, you could be able to see this video in a .mov file. And the corresponding identifiers functions had a capture so that we'd be able to pull this data from the backup. Now, the version 1 and version 2 code in this regard is mainly the same, with an exception, and we'll get down to that a little bit later. Now, we have our capture SMS function, which is going to open up the directory that we stated previously from the file iPhone backup file locations. So we're opening up this database, and that's going to be passed in ArcParse. And we're opening the connection for SQLite using SQLite 3 to be able to read the contents and then execute a command to extract all the data. So that's what's happening over here in this lines of the code from about 108 to lines 108 to about lines 126. So when we open the file, we then want to close it, and I decided instead of using a .csv to use a .text file. This was mainly for preference. I know that I like to do a lot of grep commands. I like to, if I'm working in a terminal, to remain in the terminal, and then I could do a little bit more with the data rather than dropping it in a CSV. Just kind of changes around things a little bit too much for me. So I decided to go with a .text file. And as you can see, for the remaining functions here, we have to open up those file locations with that appended, that SHA-1 name. So that's being passed through here. So we have phone calls, calendars, notes, and contacts. And our main is going to use ArcParse. So we're stating, this is a tool for extracting data from an iOS backup file. And in here is the whole bulk of it, mainly. The iOS 10 versions, there's a change here, and I'm going to go to that now so I can show you what I'm talking about here. So I'm just going to open up my Finder. I have an iOS 9 backup directory, so I'm just going to go into that. And as you can see, there's many SHA-1 files in here, and these are all our database files. So we can constantly scroll through here and see that, this is the iOS 9 backup. And the way that you can access this is through iTunes. You go to Preferences, and you would click Devices. I already did this before, and you could see all your different device backups. Now, if you're not familiar with grabbing it from there, you can also go to your folder directory, and I have here the location on a Mac OS Sierra is users, library, application support, mobile backup sync. So if we go to this real quick, these are the different backup files here. So 39, just because I know I've been using it, is my iOS 10 backup, and 87 is the one that I had for iOS 9. To go back to this real quick, iOS 9, we see that when we open up the directory structure, there's many files in this directory. There's no subdirectories or anything like that, which is why in the version 1 code we're able to just point the file directly like this, and it makes for extracting the images and the other data a lot easier because we're not having to traverse through other directories. Now, I mention this because there is a problem, or not problem, but a bit of a challenge in the iOS 10 directory structure. So I'm just going to open up this file, and as you can see, there's many subdirectories with the 2-bit value kind of from the SHA that it's taken before the title name and dumped them all into there. So I'm just going to quickly go through this here. And I'm also going to open up my info.plist, which contains a lot of the information regarding the GUID, the cell phone number, the IME, some of those important values that an attacker likes to grab right away. So, being that this file isn't encrypted, we're able to pull up this info.plist, and right away we could check to see what my cell phone number is, what's the model, what's the product, what are the different installed applications. And sorry for going through this quickly, but this is a little bit of private information here. So we have the GUID and the display name of the phone. So for my iPhone iOS 10 backup, it was CSIN, and in the iOS 9 directory, I'm not going to open up that plist, but it is CJ Sinagra. So going back to the iOS 10 directory, we can see here the many subdirectories in here, and then when I open up one of them, now it looks like the iOS 9 backup. So I knew that something needed to happen in my Python script for version 2 to be able to walk through these files and the directory structures. So as you can see, there's a difference here now, and what I'm trying to achieve is using OS walk rather than just opening up the directory in iOS 9 or iOS 10 and less is a lot different. So that was one of the changes that I had to make there. Another thing that I did was I created a fuzzying script, and I'm just going to open that up real quick, and this allowed me to kind of check if for the iOS 10 directory, if these files actually existed. This was really helpful for me to kind of do some troubleshooting and debugging to see if I'm actually getting the proper or capturing the proper files and seeing if those files actually existed. And in some of those cases in the iOS 10 backup, when I ran this, those items weren't in there, and I'm not sure if that was because I just didn't have anything saved down, which could be a possibility, or if anything else was changed in iOS 10 backups and how they are compiled. Now this fuzzying script, I'm also going to post up and submit it to my project. And it was really, really helpful. As you can see, I'm just putting out the path of where this file was, and this can be used not only for the iOS 10 backups, but for a lot of other applications and usage if you want to go through a file directory and see what was going on. So kind of a little bit of a sidestep script here that I had to create, but it was definitely helpful in going through this all. So back to my iOS Extractor v2 version and the noticing of the directory structure now. I had to use os.walk to traverse through each of the subdirectories there. And in my main, if we can continue through, I was able to locate, because the structure of the file names were the same since it's a SHA there. So for example, the SMS operator here, or file location, had this 3D appended to it, and I kind of noticed a pattern that the iOS 10 backups basically took so for notes, the CA portion here, so as you can see it's CA, 3B, C, blah, blah, blah. If we go to that CA file there, so I'm going to go back to the Finder and go to CA. These are the different files that have that CA notation in front of it, or start with that. You can also do a regular expression to be able to, search for these files if you want to in your future work. So now that we have the different functions and the identifiers, we basically pass the iOS file to the program. It's going to look at this content, open it, read it, and then execute the SQLite command that was basically taken from Craig Crosby's work. So thank you, Chris. I'm sorry, not Craig. I apologize. Now, what's going on here is I have a lot of more error handling and exceptions, something that Chris didn't have in his iOS 6 recovery tool. I thought that it was necessary to kind of go through all this step by step without, kind of erroring out on something, so that it can continue easily and gracefully. So as you can see here, for extracting or running this on the contacts list, I am creating the directory, contacts directory, using os.make directory, and I print out to the terminal, hey, we're capturing contact list, and I kind of append a a plus sign rather than doing a progress bar, which was something that Chris did, and I just didn't feel the need to incorporate that into my script here. So we make the directory, and then we pass this information to the function capture content, which is going to take the contacts list listed above over here, and it's going to then create that contacts directory, which we're doing in this area here. So I'm just going to quickly run both of the scripts. The first one I'm going to run against is the iOS 9 structure using my CS extractor tool. So I'm just going to open up terminal here, just make sure I'm in the correct directory. Going to pass Python, the CS iOS extractor version 1. And I have to throw out, well, first I'll just show what happens when we do this. Using argparse, it lets me know that I have to drop a -i after it to include the iOS 9 backup, because we're using version 1 here. So now I'm just going to put that field in there, and I'm going to hit enter to run the program. So when I hit enter here, as you can see, it lets you know that it's starting the extraction tool. We're analyzing the backup directory, and from the code you can see where this is all happening. It created the directory CJ Sinagra iPhone and the timestamp of when it was created. Um, it takes the text messages, the contacts list, notes, phone calls, and images. Right now it's doing the analysis on that. It looks like it just finished. And the voicemails, the videos, the calendar lets you know that the thing has completed, and hey, we can review the data. So let's actually just open this up in terminal. So I'm just going to do an ls, and you can see that the CJ Sinagro iPhone was open, the directory was created. So I'm just going to go into that directory real quick in terminal. Like I said, I like to stay within the shell here. So something for like, or just real quick, we have the calendar directory was created, the images, the phone calls, the video, the voicemail, the SMS messages, notes, and contacts. So I'm just going to cat the notes file, and there's a notes.txt in here. So as you can see, it looks like, oh, hey, I had a password for something. So that's kind of common, right? A lot of people like to store passwords in plain text in their notes field. And as you can see, I was doing that back, back in the past. And realized that this was really bad practice, and I think a lot of people aren't aware of that. So there needs to be some user education, and please let other people, family members, and friends know about that. So as you can see, those are the different titles there. I didn't want to go deeper into this to see what some of the other content for, like, let's say, BNY Mellon, that's a place that I worked at in the past, what that file content was. So I'm just going to clear this. I'm going to do another ls, and let's go into text messages. So I'm going to do text here, and because there is some personal text messages here, I'm just going to grep for something like hello. So as you can see, there's a lot of things and information that came up in here. I'm just going to clear that real quick. So, not to go deeper into it, but going into Finder now, if we go to images, and if I go to JPEGs, PDFs, it didn't capture anything in there, probably because there was nothing stored. But JPEGs and PNG had information and content. I'll just easily click on that to show. And another thing here is the JPEGs. So I don't want to kind of keep those open there for privacy things, but I know you could just pause it on your video. So if we go into phone calls, for example, we have the SQLite thing that it copied. That was the database from iOS 10 the iOS 9 backup, I should say. And for something like voicemails, we have the .amr files that we can listen to. I'm not going to play them. There's no need for that. So moving along here, I'm now going to run it against the version 2 of the program, against my iOS 10 backup. So let me just quickly do that. So Python, we're now going to do cs underscore iOS extractor. Oh, I don't think I'm actually in that directory. That would help if I got it out of there. So CS iOS extractor version 2 to run against the iOS 10 file. Oh, I didn't pass the file extension. Look at that. So throughout this course, I'm just going to take a little pause right there. I would consistently delete this file. I know that Chris had something like a force flag to be able to constantly run it again and again. You can do that because it's taking a timestamp, but if you're looking to do it one after another, that timestamp might not change, although it's changing by the second. I don't see how you would constantly run it every second after that. So there is an ability to run it again after it. Let me go back to terminal and type in my code, excuse me. Oh, I'm typing the wrong things. Version 2, Python. We're going to throw up that include flag, or, for pointing it where our backup actually is located. And now I'm going to say 10. So I'm going to hit enter there. As you can see, it's starting up. It analyzed the backup directory, and now we can see that the GUID changed. So now it's CSyn iPhone, and like the version 1, it extracts the text messages, content list, notes, phone calls, images, voicemail, video, and calendars. So I'm just going to now go into that directory. Sorry. Do an ls. As you can see, the directory structure was created. And for this time around, I'm not going to go to text messages, but I'll go to the, let's say, contact list. So I'm just going to do a cat on contacts, and let's try to grep for anything like, I don't know, what do you think? Let's see what Franks I got. So as you can see, there's some different people and their names, some of my friends and work people, so I'm just going to clear that out. So yeah, I mean, that's pretty much the code and project in general. So if I have the iOS 9 backup here, and this was from the iOS 10 backup running version 2 against that. I actually have in my project here, this is my project project report summary. So I go through a lot more information in here, as you can see, talking about the file directory structure. That is something that we did. You know, how the iOS 10 backup directory and iOS 9 or anything less than iOS 10 has that different structure. So ultimately, the version 1 tool can be run on the, if you had a, iPhone backup from version 6, let's say. I talk about the fuzzying script and other, testing and environment things that I was running it on. And here is, the iOS extractor tool and how it runs, which is something that I just demonstrated. This table is basically comparing and contrasting and showing the improvements and features that I made from Christopher's iOS 6 recovery to my tool. And as you can see, the main things is that for images, I figured, hey, let me include a .pdf, but you're not limited to that. I mean, this is an open source basically tool that I've created, so you can go ahead and kind of pick any other file signature that you think is in there. So that's what I did for, basically including videos, which is the .mov files. And, although this project is basically for digital investigators, it's pretty common too for, like, an attacker, let's say. I kind of thought about how, not only an investigator but an attacker can, take this information, and that's because by default, iTunes isn't encrypting your backups. And from looking at all this data and information and doing a lot of research, it's really, really imperative that you kind of take that best practice. Again, that's not something that I did, and after this project, I'm definitely going to take that into action. Like I talked about before with the notes, a lot of people save clear text passwords, which was something that I did. And moving on, I changed that, and now I think I have to do that again for my, iPhone backup. And there's a lot of tools out there too. While doing this research, that people created these backup, directories and things, um, or programs to help people, but also I think that an attacker or an adversary can use that against someone. And the reason I bring it up is, if you're not protecting your system correctly, an attacker, either physically or through the network, can extract this information and now basically has a lot of information on you. You can see from the info.p list that that I pulled up before, the different applications, your phone numbers, you can correlate now even the SMS text messages back to the contacts list, which is pretty cool. And there's a lot of other things that you could do with these data points, I should say. Um, you know, the what I've included is the CS iOS extractor version 1 and version 2, and I've outlined in the project summary that the reason for doing that. And again, you could run this against the iOS backups less than version 10, and this one you would run on version on iOS version 10 is the CS iOS Extractor version 2. That basically sums up my project. There was a lot of challenges here that I had to go through. Of course, I call it a fuzzying script. I'm not sure if that's the correct terminology. I think it is, only because there was some constant traversing and debugging that I had to do for this to make it happen. I just want to thank everyone. I had a really great semester learning about digital forensics and hope to continue. Take care and goodbye.